Okay, so this is part 284C3m1b7a20. It's line 22f1fa19c3m1b7a20. Microdiffraction, X-ray crystal pulse laser formulas, UFO 5G Wow Seti. This has keyword research PDF files and laser beam formulas. Okay, so there's the alien radio signal there. November 29th, 2012, I was working on this data, and today's December 13th, 2012. My thoughts. Based on keywords research from lines 22f1fa19c3m1b7a1 to 7a20, several videos talk about various types of new experiments and PDFs along with formula ideas for CERN and others to try. So quotes from various blogs, Microdiffraction Imaging. This is a new article, 2012, November 2012 actually, it's only a couple of weeks old. IDO1 is an X-ray diffraction and scattering beamline devoted to the study of a wide variety of materials from nanostructures to bulks with the ability to perform imaging and strain studies using coherent X-ray diffraction methods and or nano-diffraction. IDO1 is also dedicated to SAXS, GISAXS, and anomalous scattering studies. That's from www.esrf.eu. I'm thinking I should add the IDO1 into the title, and I can fit it in here. So I'm going to pop it up here just so that they know, anybody who's working on this technology will see that reference number there. Okay, figure 1b. A clear correlation is found between the shift of the tuning fork resonance frequency Fres and the lattice parameter change ASIGE as a function of the tip displacement triangle Z, which is a measure of the applied force. So that's got your sig A, kilohertz, and this here resonance frequency, sig lattice parameter. Okay. Probing the mechanical properties. So here's another quote from a PDF file again. Probing the mechanical properties of nano-sized objects by combined in-situ AFM and u-XRD technique. From 2009. The investigation of semiconductor nanostructures is widely regarded to be one of the most important issues concerning the development of new technologies on the nanometer scale. And as you know, in the last, I'd say 10 or 15 videos, nanoparticles, nanostructures, and semiconductors is a huge thing that's, there's a lot of different PDF files we found on them and also experiment results. So that's something you might want to look at. The last 20 videos, it does talk about new technology ideas actually. Although the elastic properties of bulk materials and thin films are well known, it is expected that the mechanical behavior is altered as the size of the material is reduced to the nanometer scale in 2 or 3 dimensions. To this end, we combined an in-situ atomic force microscope. I'm wondering if your nanometer structures, have you ever tried doing it in a sphere? I don't have time to Google that, but I'm just thinking out loud here. To this end, we combined an in-situ atomic force microscope, AFM, employing a tuning fork as a force sensor and X-ray diffraction with a microfocus beam, MXRD, to quantify the elastic response in nano objects during the application of a well-controlled uniaxial pressure. See figure 1a. In first conceptual experiments, SIG islands grown on SI001 were investigated. From changes in the diffraction pattern during pressure application observed close to the SI004 Bragg peak, the corresponding variations in the object lattice parameter were derived and could be correlated to shifts of the resonance frequency of the AFM tuning fork. See figure B. This correlation rendered it possible to infer the Young modulus of an individual nano-object. In summary, this method paves the way to a whole range of novel experiments on the nanoscale. So basically it opened up a door for all sorts of new things, new technologies. And again, it's at the same site, www.esrf.eu. Okay? So the keyword found in the data was X-ray microbeams and iopscience.iop.org. So I'm going to quote from Wiki. I looked it up. Some facilities have developed or are developing soft X-ray microbeams Now, isn't that interesting? Because we're talking about X-rays and microwaves, and this is an X-ray microbeam. Okay? So in these systems, zone plates are used to focus characteristic X-rays generated from a target hit by a charged particle beam. When using synchrotron X-rays as a source, X-ray microbeam can be obtained by cutting the beam with a precise slit system due to high directionality of synchrotron radiation. Keyword from data is superconducting nanoprobe for applied nuclear physics experiments. And quote from the blog. A new high-energy nuclear microbe has been installed at the Munich Tandem Accelerator. As the facility differs from the existing microbes, several parts of the system, microslits magnetic lens, there's keywords there, magnetic, have been, and lens, we were talking about mirrors, right, have been completely new designed. The facility aims to investigate special topics in solid-state physics, biology, and medicine. In contrast to common low-energy microbes, this facility uses an energetic ion beam, 25 MeV protons with a sub-micron lateral resolution. This novel approach offers new methods in the fields of nuclear analysis techniques. Measuring coincident elastic proton scattering, 3D hydrogen distributions can be analyzed in micron dimensions. Furthermore, a large magnetic analyzer behind the target can be used for high resolution. Some NM scanning transmission ion microscopy STEM experiments. Just so you know, this is going to be a long video. I didn't want to break it down because it's all related. I don't know why I didn't break it down. I think I forgot to. Sorry. Keyword and data. Scanning transmission ion microscopy. www.e12.ph.tum.de. Keyword to Google molecular ion. Quote from blog. Organic chemistry, an ion that results from the loss of an electron by an organic molecule following bombardment with high-energy electrons during mass spectrometry. And that's from answers.com. Keyword from that data is molecular ion laser beam. I'm going to quote a PDF file. Laser-induced multiple ionization of molecular ion beams N2+, CO+, NO+, and O2+. Okay. So that's from 2009, Kansas, USA. We have simultaneously measured the kinetic energy release and the angular distributions for the multiplied charged fragmentation of diatomic molecular ions N2, CO, NO, O2 in intense ultra-short laser pulses. Using a coincidence three-dimensional momentum imaging method, we unambiguously separate all fragmentation channels, including dissociation, since we measure both neutral and ionic products. Based on the experimental results, we conclude that the fragmentation mechanism that explains the multi-electron dissociative ionization of these molecular ions entails a stair-step process. This mechanism, which involves stretching the molecules prior to each sequential ionization step, is similar to that proposed in some earlier studies that we use neutral molecules as targets. We find that structure in the breakup of the molecules to lower charge state is molecule specific, while for breakup to higher charge states all species tend to follow a universal trend. And that's links.aps.org and prod.aps.org. So here's a diagram here. Schematic setup of the trap, the sources in different laser beams. So you got your cooling laser, photonization laser, optical fiber, magnesium atoms, cooling laser, dissociation pulses, radio cooling laser, and hydrogen molecules in QCL. Okay. Keywords and quotes from a blog. Structure and dynamic of few electron ions in EBIT. Okay, and this project brings together the expertise of the Aarhus group on molecular ion trapping and cryogenic know-how of the MPIK. For these experiments, there are two counter-propagating cooling laser beams in axial direction and one cooling laser beam in radial direction. Under 45 degrees, there are two atomic sources, one for magnesium atoms and the other one for molecular hydrogen. Together they make sure we have plenty of supply of Mg and H to create the Mg plus and MgH plus ions we need. On the other two 45-degree ports, there is one side the photonization beam, and from the other side a pair of dissociation laser beams enter. Under 23 degrees, an optical fiber can be positioned at the trap center in order to align and overlap the laser beams. The second 23-degree port is used for the quantum cascade laser, QCL, responsible for rotational cooling of the molecular ions. Underneath the trap there is an image intensifier and a CCD camera which images the ions. Due to the spontaneous emission of the Doppler cooling, the ions can be detected and imaged. As the cooling is applied during the whole experiment, the activity of the ions can be followed through the experiment, loading an Mg plus a column crystal. Singly charged magnesium ions are produced via photonization. First one evaporates neutral magnesium from an oven. Then the atomic beam is overlapped with the photonization laser beam at the center of the trap. For the Doppler cooling, 2 or 3 laser beams with a wavelength of 280 nm are used. These drive the electric dipole transition that couples the S1 half and the P32 state in Mg+. It forms a closed 2-level system, which is important for the Doppler cooling of the ions, as many absorption decay cycle can be performed. With Doppler cooling, the ions are translationally cooled down to a few mK. At these low temperatures, the ions are forced toward the lowest potential, the trap center. But when the ions get this close, their mutual repulsion due to column forces become apparent. They arrange in a symmetric form, a so-called column crystal, with distances of a few between the ions is created. So there's a crystal structure, different in cap, potential, CCD, and we're almost done. CCD images of smaller crystals where single ions can be resolved. Okay? Notice the patterns in a circular pattern there. So November 28th, my thoughts. Just to speed things up, instead of reading everything posted on the blogs, I pulled out the keywords that stood out to me in relation to the train of thought. Thank God I did. This video's long. We're discussing in the videos. Keywords from data that I picked out, quotes from various blogs. Okay, formation of cold MgH molecular islands. MgH plus molecular islands can be formed by photochemical reactions with neutral H2 molecules, and there's the equation for it. And that's from www.mpi-hd.mpg.de. Okay, so resonant multiphoton ionization of H2 plus, and that's from jrmphysKSU.edu. There's their link there. XUV laser pulses, adsab.harvard.edu. Nanoplasma energy, pr.aps.org. So November 29th, the formula based on the data keywords. Okay, Mg plus column crystal, diatomic molecular ion beams, N2 plus CO plus NO plus NO2, ultra short laser pulses. Laser beam strategies, Airhus group, MPIC experiment data. MgH molecular islands, neutral H2 molecules, resonant multiphoton ionization H2 plus, HUV laser pulses for the laser beam gun ideas, nanoplasma energy mixed in with Xray, see alien technology formulas in the Wildline 22 videos, in 19C3M section of video. I just ate breakfast, sorry. Okay, sorry that was so long. I think the other ones will be a little shorter, I hope. Thanks for watching.